Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is the important concepts of equation of perpendicular bisector in complex numbers. This is the standard equation of the perpendicular bisector in complex numbers. An important advice: we must always be good to others. You can find the link of the math website in the description, where you can find the soft copy of this lecture. This is the standard equation of the perpendicular bisector in complex numbers. In this equation, z is the variable point and u and v are two complex numbers. And these two signs are the part of the equation. And both the complex numbers must be inside the brackets. Hence, in this equation, the locus of z is the perpendicular bisector of the complex numbers u and v. So, if this is u and if this is v, then this is the locus of z, the perpendicular bisector of these two complex numbers. And z is anywhere on this line. Perpendicular bisector divides this line uv into equal parts and makes 90 degree with this line. Shade the region which satisfies this inequality. According to this inequality, z is nearer to v than u. So you have to shade this side of the bisector, the v sides of the bisector. You can understand this concept through this example. If z is here, then z minus u distance is greater than z minus v distance. So if z is anywhere on this region, then this inequality will always be verified. Well, you can also understand this concept through this sign of inequality. This inequality sign is pointed towards v. So you have to shade the v side of the bisector. This is the required region. Z is anywhere in this region, either on this bisector or anywhere in this region. Another example. Z minus I is greater equal to Z minus 2. So first you have to draw the bisector of these two complex numbers I and 2. This is I and this is 2. Therefore this is the bisector of these two complex numbers. Now you have to shade the two sides of the perpendicular bisector, this side of the perpendicular bisector, because this inequality is pointed towards 2. So Z is anywhere on this bisector or here, or in this region in fact. Another example. Here we have to first draw the bisector of 0 and 2. This is 0 and this is 2. So this is the bisector. Now we have to shade this side of the bisector, the two side of the bisector, because this inequality is pointed towards 2. Another example. First we have to draw the bisector of these two complex numbers 3 and 3i. This is 3 and this is 3i. So first join these two and this is the bisector of these two complex numbers. Now you have to shade this side of the bisector because of this inequality. This inequality is pointed towards 3, so shade this side of the bisector. Next example. Given argument z is less than equal to argument u, where u is this, shade the region which satisfies this inequality. And this is the domain. We have to shade according to this domain. Since this is u, and in Argand diagram u is here, and this is the equation of y is equal to minus x, so the argument of u is 135. So argument u is 135, therefore argument z is less than equal to 135. And according to this domain, we can say argument z lies between 0 and 135. So we have to shade this region. Z lies anywhere in this region, either on this line or here. Next question. Shade the region which satisfy these inequalities. So first we have to draw the bisector of 0 and 2. So this red line is the perpendicular bisector of these two complex numbers 0 and 2. And according to this inequality, we have to shade the 0 side of the bisector, meaning this is the required shading. Now we have to sketch this complex number, the locus of z in this inequality. So argument of z from u, this is u minus 2 plus I, this is here. So we have to make 45-degree line from u. So for 45-degree line, since we are going 2 units right, so we have to go 2 units up. So this line must cut the imaginary axis at 3. This is compulsory. I have discussed these things in detail in my argument lecture. So this is the 45-degree line. And according to this inequality, z lies between these two lines. And according to this inequality, z lies here. So we have to shade the common region. So this is the common region, this triangular part. This is the final shading. Z lies anywhere in this region. Next example. Shade the region satisfying the inequalities. Z minus I is less than equal to 1. This means circle with center at I and radius 1. So here is the circle with center at I and radius 1. This is u, 1 plus root 3I. Its argument is pi by 3, 60 degrees. So this line is here, u, and according to this inequality, argument z is greater than argument u, and argument u is 60 degrees or pi by 3. So z must be here. According to this inequality, z is inside the circle or on the circumference. And according to this inequality, argument z is greater equal to pi by 3. So z must be here. Example question number 3. Number 1. Find the modulus and argument of u. Since this complex number lies on y is equal to x, therefore its argument should be pi by 4 and its modulus is under root 8, which is 2 root 2. Sorry. The second part of this question. Sketch an Argand diagram showing the points representing the complex numbers 1, I, u. Shade the region whose points represent the complex numbers which satisfy these inequalities. This is the inequality of perpendicular bisector of 1 and I, and this is the inequality of the circle with center at u. And u is 2 plus 2I. So here is the circle with center at 2 plus 2I and radius 1. And according to this inequality, we have to shade inside the circle. And this is the inequality of the perpendicular bisector. So this is 1 and this is I. And this is the perpendicular bisector of these two complex numbers. Since this inequality is pointed towards 1, so we have to shade this side of the perpendicular bisector. And since this inequality, this equation, modulus has lesser equal sign, we have lesser equal sign, so z is inside the circle. So we have to shade the common part. This is the common region. This is the required region according to these two inequalities. Here is the required shading. See, z is pointed towards 1, so z is either here or according to this inequality, z is inside the circle. So this is the required region. And this circle has radius 1 unit, and the modulus of a center is √8. This will help us to find this angle. Now the next part of this question. Using your diagram, calculate the value of modulus z for the point in this region for which argument z is least. We need the smallest value of modulus z when argument z is least. So argument z, to find the position of z where argument z is least, we have to draw a tangent from origin to circle. So if we draw tangent from origin to this circle here, and if z is here, then this is the smallest argument, and we need this distance. The question is, find the value of modulus z for which argument z is least. So try to understand this thing. If z is here, then argument z is least, and we need this distance. So this is the requirement. So always read the question carefully. Find the value of modulus z for which argument z is least. For argument z least, draw a tangent from origin to this circle. Here is the solution. Let me solve this part here. So we need this distance. So this is very simple. By using Pythagoras, we can easily get this distance. Let me show you the correct, fair solution. Here is the fair solution. Under √7. We need this distance. The next example question. Question number 9 from my practice book. The first part of this question, express u, find the modulus and argument of u. So to find modulus and argument of this complex number, first we need to rationalize this complex number. See, when you will rationalize this complex number, you'll get this answer, minus 3i. Now we have to find its modulus. The modulus of this complex number is 3. And since this number lies here, so its argument must be negative pi by 2. This is what we had to show. We had to show the argument of u is negative pi by 2. Now the second part of this question. For complex numbers satisfying this equation, find the least possible value of z. Least possible value of modulus z means the shortest distance of z from origin. So first sketch this complex number. You can sketch this complex number in this way. See. You have to sketch z from u, and u is minus 3i. So this is minus 3i, and this means y is equal to x. So this is the locus of z. This is the locus of z. Z is anywhere on this line. So make a line from minus 3 of gradient 1. Means if you are going 3 units right, then you have to go 3 units up. This number must be 3. Check this again. Now the next part of this question is find the least possible value of z. Modulus z means distance of z from origin. For that you have to draw a perpendicular from center to this line. So when z is here, then this distance is the smallest, and we need this distance. See, this angle is pi by 4, this is also pi by 4, and because of this 90 and this pi by 4, this is also pi by 4. So we can either use Pythagoras or sine theta in this triangle. I'm using sine. Sine pi by 4 is under root z over 3. This distance is 3. This is root 2 upon 2, so 3 root 2 upon 2. That's the final answer. Let me show you the fair solution of this question. Wait a minute, please. So the fair solution of this question is here. See, this is the locus of z. And when z is here, then this distance is the smallest. So you can either use Pythagoras or sine theta or cos theta in this triangle. That's the final answer. What if the question is find the equation of this line? This is an extra work. So first find angle of this line. Gradient of this line. The gradient of this line is 1 because m is equal to tan theta. And the intercept of this line is negative 3. So the equation will be y is equal to mx plus c. So y is equal to y is equal to mx plus c. So y is equal to 1x minus 3. This is the required equation of this line. If the examiner asks find the equation of this line, then you can find the equation of this line in this way. First find the gradient and then substitute gradient and c into this equation. This is an extra work. Now the next question, next part of this question. The next part of this question is, this is the equation of circle. Find the greatest possible value of modulus z. This part is very simple. Number one, we have to simplify this equation. We had u here and the value of u is minus 3i. So by multiplying minus 3i with this, we have this, and this is the standard equation of circle. The center of this circle is at 3 minus 3i. And the modulus of this center is 3 root 2. Now we have to sketch the circle. Since center is at 3 minus 3i, so this circle must be in 4th quadrant. And this is the modulus of the center, 3 root 2. And this is the radius of this circle 1. We need greatest possible value of modulus z. Greatest possible value of modulus z means maximum distance of z from origin. So this is the maximum distance of z from origin. When z is here, then this distance is greatest. So the answer is 3 root 2 plus 1. What if the question is find the least possible value of modulus z? Then z must be here. And this is the smallest distance of modulus z. So this should be 3 root 2 minus 1. This is an extra work. The next question in fact, 16 from my practice book. On a sketch of an argon diagram, shade the region whose points represent complex numbers satisfying this inequality, and this inequality. We have 3 inequalities. Circle, y is equal to minus x line, and this means x is greater or equal to 1. Real part of z greater or equal to 1 means x is greater or equal to 1. First we need to simplify this. 2 minus 2i. So circle with center at 2 minus 2i and radius 2 units. This is the circle. With center at 2 minus 2i, and radius is 2 units on Argand diagram. This is the circle. Now the next thing is, we have to draw this line, argument z less than equal to minus 1 upon 4. This is the line, minus pi by 4. See, according to this inequality, z is inside the circle. And according to this line, argument z less than equal to minus pi by 4 means this is the required region. Because minus a small angle less than 45, angles which are less than minus 45. So minus 60 is less than minus 45. So this is the required region according to this inequality. And third inequality is let me sketch this here. This is the second inequality, pi by 4 angle, and this is the third inequality, x greater equal to 1. So this should be here. This is 1. So x greater equal to 1 means the required region is here, and this means z lies inside the circle or on the circumference, and this inequality means z is here. So we have to shade the common part. This is the common part. So this is the region where z lies. Now the next part of this question is, calculate the greatest possible value of real part of z for points lying in the shaded region. Real part of z means greatest possible value of x. Real part of z means x. So we have three possible positions of z. This is the first position, this is the second position, and this is the third position. And we need the maximum possible value of x. So when z is here, then this distance is greatest from origin. So we need this value of x. And we can easily find this value because we have this total length. This total length is modulus of the center, which is I think under root 8, and this is the radius 2, and this angle is pi by 4. So in this triangle we can use cos theta. Pi by 4 under root 8 plus 2, we need x. So by using cos theta in this triangle we can get the greatest possible value of x. So this is a way to solve this question. Let me erase this working and let me show you the fair solution of this question. See, this is the required region, and when z is here, this distance is greatest. And by using cos theta in this triangle, we can easily find this distance. So the answer is 2 root 2, 2 plus root 2. Give your answer in exact form.